This is a combination of 4.4 and 4.5. Okay, the first is the idea of congruent figures. So remember, here's the symbol for congruence. Congruent means that they're equal in all respects. And so everything about them is equal. And with respect to the transformation rules, that if two figures are congruent, they can map directly onto each other. Using the rigid transformations. Remember, we talked about rigid transformations are ones where the shape and size don't change, or only the position and orientation. Okay, so it might be turned from a rotation, it might be reflected, it might be shifted. Okay, so those are the rigid transformations. If that's all that's being done between two figures, then they are congruent. Okay, they're the same measurements. All angles are the same, all sides are the same. And so if you have a congruence transformation, it just means that the preimage and the image are congruent. Okay, and that's just giving you that the side and angle measures are preserved or the same. Now, once you start getting into 4.5, which is dilation, so the last two definitions are from 4.5. Dilations change the shape or change the size of a figure without changing its overall shape. Okay? And so it just becomes an enlargement or a reduction of the same original figure. And it's going to change by a factor, or by some dilation factor or a scaling factor. Okay? And so an enlargement means that the scaling factor is greater than 1. And so again, this is one of those cases where you might want to leave a note to your future self to understand that means that greater than 1. And then actually let me put it in a, different color. So enlargements are greater than 1, and a reduction, the scale factor is going to be less than 1. So it's going to be a fraction smaller than 1. Okay, and so that's what you're looking at with dilations. Okay, so the figure is going to get proportionally bigger or proportionally smaller than the original preimage. Okay, and so if that is the case, then you have what are called similar figures. We will be talking more about similar figures and especially similar triangles. Okay, but similar figures, the symbol for similar is just this tilde mark. Okay, and in similar figures, you're going to have corresponding angles that stay equal. But the corresponding sides can be proportional. Okay, so similar figures are ones where there might be, or there's a dilation that is applied to it. Okay. All right, so if we look at this first example up here, and we're asked, what is the scale factor? Okay, if you're mapping 6 onto 14, so the first thing to to think about here, if we're taking 6 to 14, okay, is that going to be an enlargement or a reduction? Are we making it bigger or making it smaller? We know it's bigger, right? We're going from 6 to 14, it's bigger. So that means this dilation is an enlargement. That's probably the easiest thing to find first in a question like this, is determine, are you looking at something that's bigger or smaller? And when you compare these two lengths, your scale factor is either going to be the ratio of one over the other. Okay, so when we look at this, if we know it's going to either be 6 to 14 or 14 over 6, if we want the one that's an enlargement, which one does that make it? The one that gives you a value greater than 1, right? So that's where that greater than 1 comes into play. So if you figure it's an enlargement, you know that your ratio has to be greater than 1. Find the one that gives you that. Okay, so try the second problem here right below this. See if you can answer that using this same kind of pattern of reasoning. Mapping a side of 18 onto a side of 12, are you making it bigger or smaller? This one's a reduction, so you know that this is going to be less than 1. So when you look at these factors, it's 18. The ratio of parts is either going to be 18 to 12 or 12 to 18. Which of these is less than 1? 12 to 18. Now you could reduce this, right? These both have a common factor of 6. You could reduce this to 2 over 3. Either of those are going to be acceptable. Okay, but that is how you find your dilation factor, your scale factor. All right, pretty straightforward. Okay, it's going to be, again, one or the other. The neither there is just a distractor. Okay. All right, the final slide for Chapter 4 is going to talk about some similarity transformations, and that's where you're going to have some kind of a shifting followed by a scaling of it, or a dilation of it. Okay, so just by definition here, we're looking at a transformation where the pre-image and image are similar. Okay, so that means that there's going to be a dilation applied. Which is why it talks about the similarity here. Okay, they don't necessarily have to be congruent. It is possible that they remain congruent, okay, but it is going to preserve the angle. Okay, and again, this means that you're going to see a dilation applied. All right, so here's how you're going to work with these dilations. And once more, they can be enlargements or reductions. Either one is considered that dilation. Okay, and when you look at the transformation, you're going to be given a set of points, and you're going to be given a set of rules. And you're going to follow these rules, and you're going to follow them in this particular order here. Okay, so you're going to do the translation first. Okay, so you apply the shift first, okay, and then you're going to apply the dilation. So if you look at this point, we'll look at point A and point B here. If we look at point A, starts at 2, 6. When we apply this dilation, or when we apply this shifting, the translation, what's the new set of coordinates going to be for A? 2 plus 6, which is 8. 6 plus 2, which is also 8. So that's the first step of that transformation. And then you're going to apply the second step here, which is to multiply by 5. So this is the dilation. So we see the dilation factor of 5. And so what is 8 times 5? 40. 8 times 5? 40. And so that would be your new point A. So you're going to build it from the original and apply each of those transformations. And so I want you to try B on your own. Okay, what would be the new coordinates for point B after this transformation? So B has an x coordinate of 4, which we're adding 6, so we get it 10. We're going to start with a y coordinate of -4 and add 2, leaving -2. And then we're going to multiply by 5. So 5 times 10 is 50. 5 times -2, -10. There is your new ordered pair. Okay. All right, so final question here. See if you can find what would be the new coordinates of the points given the translation and dilation of that last problem. This one you can see is a reduction. All right, so let's apply these transformations here, starting with the shift. So we take each point and we're shifting it, the x's we're shifting 12 units to the right, the y's we're shifting up 6 units. So 12 plus 12, 24, 4 plus 6, 10. So here would be my first sort of iteration of the transformation. And then I'm going to multiply by this scale factor of 1/2. So if I multiply 24 by 12 or by 1/2, I get 12. And if I multiply 10 by 1/2, I get 5. That would be my new point. Okay. Same with the b's. We're going to add 12 to the x-coordinate, so -8 plus 12 gives you a positive 4. -12 plus 6 gives you a -6. Or sorry, plus, oh yeah. Okay, and then we're going to cut each of those in half. When we cut these in half, half of 4 leaves you with 2. Half of -6 leaves you with -3.